Hello, this is my final project for Professor Stein's computer vision course. My project is on enhanced cat detection in domestic environments using machine learning. This is my cat that I used for data in this project. As for my motivation, I wanted to be able to detect cats in various domestic environments, simply to improve the overall size and accuracy of standard cat detection systems. Now, I know a lot of you might not think there are real-life use cases, but there are. Such as pet monitoring systems, those automated pet interactive devices, and there are also people who like to study the behavior of domestic animals. As for the subject material from the class itself, as for feature detection, I used a pre-trained CNN being convolutional neural networks. I used a pre-trained CNN for feature extraction, but I focused more on extracting deep features from images using a pre-trained VGG16 model. As for image transformations, I apply transformations to images as part of the pre-processing before actually feeding them into the neural network. As for my feature descriptors, I use VLAD, which is a vector of locally aggregated descriptors for encoding. It acts directly as a feature descriptor by, essentially summarizing the information from the features extracted by the CNN. As for the neural networks, I'm using a convolutional neural network, VGG16, to extract deep features from the images. Speaking of images, image classification, I'm classifying images to detect the presence of cats, which ties into neural network applications within, image classification itself. As for convolutional neural networks, specifically, I use the VG16 model, as I've said 100 times already, to extract features, making it a direct application of CNNs. And lastly, in terms of bag of words methods, while I do use VLAD for my personal implementation, I do also use bag of words along with some other models for a baseline. Now, to dive a little deeper into one of the subject class materials, how I'm kind of exploring the feature extraction for neural networks and CNNs. This is a slide from earlier this semester that spoke of perceptron, which is a single layer neural network. It is rather simple and it implements a binary classification. As you can see here, I use VGG16, which is significantly more complex. And while they both operate on a fundamental neural network principles of weighted inputs and trainings, they adjust their weights or their weights or parameters based on errors and thus improving their predictions over time. So perceptron can kind of be seen as almost a fundamental stepping stone that will lead to more advanced architectures like the VGG16 model that I'm using for this project. In its name itself, it has 16 layers. Each of these layers are capable of capturing a wide variety of features at multiple levels of abstraction. Now, this is my actual code. This is part of a machine learning workflow that processes images using the aforementioned VG16 model. I did start with using with TorchNoGrad. This allows me to only make forward passes. It disables the gradient computation, ultimately reducing memory and speeding up computation by a lot. I wish I did this sooner. And as for this for loop, I iterate over the data loader, which automates the batching of data from the data sets. Each iteration provides a batch of inputs, image sensors, and their corresponding class labels. As for this first output statement here, it batches the image data input. They're passed through the VGG16 feature extraction layers. Once that happens, we have the feature model. It will be reshaped into the output tensor. This will keep it the correct size while flattening the remaining dimensions here. This is needed because we need to convert the multidimensional feature tensors into a 2D shape. This will make each row represents a flattened feature vector of an image. Lastly, features and labels are both arrays. Features is going to help transfer from the tensor outputs from the GPU to the CPU. It will then convert it to a NumPy array and then add it to the features array. I made these parallel, so then with the same input in class, I parallelly will add the class's specific label as a NumPy array to labels. So these are going to be parallel with that. This print statement is just for me, so I know which batch is currently processing. As for my overall method and how I tackled this project, first I had my data set preparation. My data set included approximately 1,000 images. 500 were positive and 500 were negative. This simply means that there were 500 images that were cats, aka this guy right here, and 500 negative images, things that weren't cats. As for what I used for my negative images, I used like my mom's dog. I also used just various other animals off the internet and a copious amount of Pokemon. And as for my positive images, obviously it was circled or focused just on this cat, but I did try to get multiple angles, various lightings, various locations within a domestic setting. I then moved on to the deep feature extraction, which again, I use VGG16 for my model for its sheer capability to extract rich features from images. I used PyTorch to pass each image through VGG16 to extract the feature vectors. As for my Vlad encoding, I implemented the Vlad algorithm to aggregate the deep features extracted from the CNNs. As for my CVM classifier training, I decided on sklearn as my SVM implementation. And after testing, I was able to determine that a polyterminal was best for my data. Real-time detection system, I just simply used my webcam. There's a nice OpenCV. I used OpenCV in an ongoing loop to capture live frames and be able to determine if it was or wasn't a cat based on that. Lastly, for performance evaluation, I use the classification report from sklearn.metrics to give me important metrics. These metrics are things like precision, recall, F1 score, stuff like that, which we will talk about later. Lastly, here's a short demo vid going on here. So as you can see, it shows me here. I just kind of sit here awkwardly to show that I am not a cat. I also show a Snorlax that was also not detected as a cat. Finally, my cat, who is right down here, you can kind of see his ears. Once he's lifted into frame, a cat has been detected. He is a little fidgety, and I noticed once I turned him to the side there, it briefly said that there was no cat detected, which makes me sad, but essentially, yeah, I have nothing to say about that. And again, once the cat was out of frame there at the end, it said no cat was detected. So moving on from that, as for my experiments itself, I did use the Hawkpost BattleWords model and a standalone VGG16 model to kind of get a baseline for what I'm testing against, and it yielded an accuracy of 0.52 or 52%. And after my implementation of Vlad encoding with SVM, I yielded an accuracy of 67% or 0.67. So that's an increase of 15% or 0.15. As for exploring the results, we can talk more about exactly what I got here, but through my performance metrics with classification report, I was able to not only generate these 4 important metrics, but it also told me the best parameters found for the most accurate results. Now, as for what these actually mean, the precision is simply the ratio of correctly predicted positive observations to the total predicted positives. Recall is the proportion of actual positives that were correctly identified by the model itself. The F1 score is kind of like an average between the two, but it's more of a harmonic mean, which simply means it can provide a more balanced measure by penalizing the extreme values. And the support is simply the total number of actual occurrences of the class in the specified data set, kind of showing us if it's relevant based on the context of the database's size. So now for my actual Vlad encoding. This is where I actually do the encodings and training. Obviously this first little block here, you can again ignore that print statement, that's just for me, but first I encoded the features. The Vlad encoding process is applied to the features I extracted previously. Vlad then will reshape the features to make sure it's a 2D array suitable for processing, and then we'll apply it to my Vlad function. Next, I would actually split up the data for training. I do this to train and test the subsets. You need to do this to, make sure that my model's not just memorizing the data, but actually like learning from it to generalize from it. And lastly, the actual training of the model once you split everything up. Here, the classifier that I made it with a linear kernel, as well as I made the class weight balance to handle imbalance effectively. And yeah, I set gamma to scale to automatically adjust the kernel's coefficients to fit the data without, essentially overfitting it. And this kind of, gloss through my specific algorithms and such. So thank you for watching.